Welcome all my dear students. This is lecture 2 on units and dimensions. I am Bidhubhusan Nayak, the physics teacher. In the lecture 1 we have already studied what is physical quantity and how it is classified into fundamental and derived quantities. You know, physical quantity is a measurable or observable quantity which are very much essential for expressing physical laws or laws of physics, and those quantities are measurable by the use of physical instruments. In this lecture we'll study about units, system of units, what is S.I.system of unit. Those things will be discussed in this lecture. Let's get started. But before starting, I must say one thing to all of you. Please do subscribe to this channel, like it and share it to your friends so that knowledge will be transferred to different persons, which is very much essential, especially during this lockdown period where the students will be very much benefited from this initiative of mine, and this has always been the prime motive behind my initiative of this. So let's get started. First we must know what is unit. You know, for measuring a physical quantity and expressing it, we need certain units. So, if you want to properly define units, then you can say that unit is an internationally accepted standard for measuring a physical quantity. You see, unit is an internationally accepted standard for measuring a physical quantity. So for note making, you must be prepared with pen and paper. See, for example, suppose there are two places A and B. Take it for example, A is your home and B is your school. Then if the distance between these two places is suppose 2 kilometers. This is how we express the distance, is not it? So 2 kilometers. So here, this after measuring this distance either by a tape, distance is always measured by instrument, that is the measuring tape for bigger distances, and for smaller lengths we usually use the scale. So definitely for measuring any physical quantity we always need some instruments. So this is 2 kilometers. You see, this measurement value consists of two parts. One is numeric part and another is standard part, or this is numeric part. This measured value consists of two parts. One is numeric part and this is standard or unit part. So every measured value can be expressed as a product of n u. N is the numeric part and u is unit or standard part. It's internationally accepted standards. And these units are also used for relative comparison of various measurements. Suppose one measures a distance to be 5 km and another distance is suppose 2 km. Obviously we can compare and reach at a conclusion that 5 km is bigger than 2 km. Unless we are having any units, how can we compare between different measurements? So for that purpose, unit is definitely required. So you see from this equation what we can follow is m is equal to ne. M does not change no matter whatever units you may use. M is the measured value of the physical quantity. Whatever physical quantity you measure, its measured value is capital M, suppose. So if you use a bigger unit, that is bigger unit, then the numeric part will be smaller. And if you use a smaller unit, the numeric part is bigger. Because that product remains unchanged. M does not change with the change in unit. Suppose 2 kilometer, we can express 2 kilometer as 2000 meter also. You see, kilometer is a bigger unit of distance, whereas meter is a smaller unit of distance. So when the bigger unit is used, numeric part becomes smaller, that is 2. And when the smaller unit is used, the numeric part becomes bigger, that is 2000. So we can say that finally, numeric part is inversely proportional to 1 by u. Inversely proportional to u or directly proportional to 1 by u. So that the product nu becomes a constant. So it can be a question, multiple choice question in competitive exams, that when n and u are numeric and standard parts of a measured physical quantity, then what is the relation between them? Options will be there, whether n is directly proportional to u, or n is inversely proportional to u, or n is independent of u. What will be your answer? Answer will be simply n is inversely proportional to u. When n increases, u decreases, and when n decreases, u increases. So this is all about the measurement of physical quantities. Then what are the various systems of units? Of course, throughout the world, various units are used for physical quantities. Not necessary that length is measured always in meter, terms of meter. Somewhere it is also measured in terms of feet, or foot, or inch. So there are various types of units available. So for that, we need a proper system of units. So if you want to define this system of unit, before going into details of the systems of units, what are the various systems of unit, you must know what is a system of unit, and proper definition will be a system of unit is a collection of units which contains certain number of fundamental units from which other units are obtained. So as I discussed in the lecture 1, the physical quantity is divided into two types, fundamental and derived quantities. Similarly, the unit of fundamental quantity is known as fundamental units, and the unit of derived quantities is also known as derived units. So for various systems of units, the fundamental units are different. So units of fundamental quantities are known as fundamental units, and units of derived quantities are known as derived units. So what are the various systems of units existing in the world? So these are the various systems of units, that is CGS, FPS, these are basically the systems of units existing. So CGS, C stands for centimeter, G for gram, and S for seconds. So obviously in the CGS system, there are three fundamental quantities with three fundamental units. Fundamental quantities being the length, mass, and time, with the units are centimeter, gram, and second respectively. Similarly, FPS is also there. There is also three fundamental quantities. are fundamental units, MKS 3 fundamental units, meter, kilogram, second, and MKSA another addition took place. You see, in earliest times during the 19th century, this CGS and FPS were of use. CGS is also known as Gaussian system of units, and later towards the beginning of 20th century, around 1901, this MKS system evolved, with meter, kilogram, and second being the fundamental units of length, mass, and time respectively. And then a further extension takes place when ampere, which is used for measuring electric current, was introduced or was added to the existing MKS system of units. And eventually came the SI system of units, which evolved out of a meeting held by General Conference on Weights and Measures in the year 1971. So this is most widely used system of units. Of course, in USA, MKS system is also used to some extent, but SI system is the most widely accepted used system of units, and during our further study we will describe all the physical quantities in terms of their SI units only. So you must know what is SI unit system, international or international system of unit. SI stands for System International or International System of Unit, or you can say International System of Units. The SI system of units, there are 7 fundamental quantities like mass, length, time, temperature, electric current, luminous intensity, amount of substance. These are 7 fundamental quantities with their units, and these units are, for mass units is kilogram with its symbols means kg, and length is SI unit is meter with its symbol m. These are the SI units of the corresponding physical quantities. Then time, for time it is seconds, our symbol is S. Temperature, it is Kelvin, symbolized by K. Ampere, A. And luminous intensity is expressed in terms of candela and symbolized by CD. Then 7th one is amount of substance. Amount of substance unit, that unit is mole and symbolized by MOL. So these are the 7 fundamental units from which all other derived units can be obtained.